Nobody has ever seen the edge of space. Not because we haven't looked hard enough, because there may not be one. That thought seems simple at first, but sit with it. Really sit with it, and something starts to shift inside you. Because a universe with no edge isn't just big. It isn't just vast in the way oceans are vast, or the way a desert stretches further than you can walk. It means something else entirely, something the mind was never equipped to hold. We spend our entire lives surrounded by things that end. Walls, roads, conversations. Even the sky above us ends, technically. A thin membrane of gas, and then the cold dark begins. Everything we've ever touched, measured, or named has a boundary. That's how we understand objects, by where they stop. So what happens when you remove that? What happens when you take the largest object we know, the universe itself, and discover it may simply continue, without interruption, without a wall, without a void waiting on the other side, without any other side at all? What you're left with isn't wonder. Not at first. It's something closer to vertigo. Astronomers have been staring into this problem for a long time. The universe we can observe, the sphere of space from which ancient light has had enough time to reach us, stretches roughly 46 billion light years in every direction. That boundary is our cosmic horizon, but it was never meant to be mistaken for a fence. It's not where space stops, it's where our vision does. Everything beyond it exists in a silence we can't penetrate, not because it isn't there, but because the light from those regions simply hasn't arrived yet. Some of it may never arrive. The universe is expanding, and in the furthest reaches, that expansion outruns the speed of light itself. Whole regions of space are moving away from us faster than information can travel. Which means there are places that exist, genuinely exist, that we will never see. Not with better telescopes, not with more time. They're real, and they're permanently invisible. And that's just the part of the universe we can partially describe. When physicists try to measure the actual shape of space, its curvature, the geometry of reality itself, something strange emerges from the data. The cosmic microwave background, the faint glow of light left over from the early universe, tells us that space appears to be flat. Not flat like a table, but flat in the geometric sense. No detectable curve in any direction. And flatness, in the mathematics of cosmology, doesn't imply a large finite space. It implies an infinite one. Not probably, not loosely. The equations, taken seriously, describe something that goes on without end. The scientists who work with this data don't say it casually. Infinity isn't a word you throw around in a physics paper without weight. But the measurements keep pointing the same direction. And the direction is, there is no edge. Now, here is where the story stops being about telescopes and starts being about what that actually means. If space is truly infinite, not poetically, not as a figure of speech, but as a physical geometric fact, then distance stops meaning what it normally means. In a finite universe, the furthest point is a meaningful phrase. In an infinite one, it dissolves. Every location is equally central. Every direction goes on equally forever. You are, right now, sitting at the center of an infinite space, and so is everything else. But there's something else that follows from this. Something that cosmologists accept, but almost nobody outside physics ever hears clearly stated. In an infinite universe, filled with matter, which, as far as we can measure it is, probability and repetition become inevitable. There are a finite number of ways particles can arrange themselves in a given region of space. In an infinite space, every one of those arrangements happens. Not might happen, does. An infinite universe is not a space of possibilities. It is a space where everything that is possible is also certain. That means somewhere in this universe, at a distance so incomprehensible that any number you could name would be laughably small, there is a region of space arranged exactly like this one. The same galaxies in the same positions, the same planet, the same life. Not a copy, not a simulation, a genuine repetition, born from the mathematics of infinite space. Physicists call these Boltzmann configurations. The nearest statistical duplicate of our observable universe sits, by calculation, at a distance of roughly 10 to the power of 10 to the power of 28 meters. That number has no name. It can't be written in any useful way. But in infinity, it's just a distance. It exists. Most people hear this and feel something crack slightly in their thinking. That's the right reaction, because this isn't science fiction. It's a direct consequence of the geometry, if the measurements are correct. And here's what makes it genuinely unsettling. Not the duplicates, not the distances, but this. We can't verify any of it. Our cosmic horizon is a hard limit on knowledge, not just a limit on technology. The expansion of the universe carries information away from us permanently. There are true facts about the structure of reality that cannot, even in principle, ever be confirmed from inside this universe. We can write the equations, we can trace the logic, but the evidence we would need is locked on the other side of a boundary that light itself cannot cross. This is the part that science rarely pauses on, but should. We are beings with finite senses, living inside something that may be infinite, asking questions that the laws of physics may permanently forbid us from answering. We build instruments, we refine measurements, we push the precision of our observations to extraordinary limits, and the universe responds by expanding, quietly, constantly, carrying the answers with it. What does it mean to live in a place you can never fully see? What does it do to the project of understanding, that deeply human need to map things, to name edges, to draw borders around what is, when the thing you're trying to understand has no edges to find? Some physicists suggest the correct response is humility. Others say it's the most exciting discovery in the history of science, that reality is not only larger than we imagined, but potentially larger than we are capable of imagining. That the universe isn't hiding its scale from us out of indifference. It simply has no scale we could ever measure. There's an old human reflex, when standing at the edge of something vast, to look for the other side. At the shore of an ocean, the eye searches the horizon for land. Standing in a desert at night, the mind reaches past the darkness for the boundary of the sky. We've always reached for edges. It's how we orient ourselves. It's how we understand where we are. But what the data keeps suggesting, quietly, persistently, in the language of geometry, is that this time, there is no other side. No far shore, no final star where the dark begins and something else takes over. Just space, continuing in every direction, without interruption. And we are somewhere in the middle of it. Not metaphorically, not as a poetic thought to sit with at the end of a long day. We are literally, physically, geometrically, in the middle of something that has no end. And the silence of that isn't frightening because it's empty. It's frightening because it isn't.